Before humans ruled the world, planet Earth was a land of giants. Snakes the length of buses.
I am still, to this day, completely amazed by this animal.
Ocean killers with jaws big enough to swallow a person whole.
These jaws were able to rip out this big chunk of car.
And predators that dwarf T-Rex.
We're talking something of enormous length that could slice you with one motion.
But of all the creatures that have ever lived, which is the biggest? Using the latest discoveries and cutting-edge science, we're going to reveal a top 10 of the biggest beasts ever that have walked the earth, swum the seas, and soared the skies.
This is awesome.
Analyzing the ultimate giant beasts across the animal kingdom, species by species, and using length as our ultimate guide, we count down from 10. And first on our list is a creature you'd never expect. A terrifying beast. The biggest insect that ever lived. Long before the dinosaurs, a winged giant terrorized the skies. Flying at over 20 miles per hour, and with jaws that could cut small reptiles to pieces, its common name is the griffin fly. A clue to this ancient megabug was discovered in 1940 in Noble County, Oklahoma, in the southern United States. Today, it's the job of insect expert Brian Farrell to take care of that clue. A fragile fossil that's 275 million years old.
This really is a spectacular fossil.
This fossil is the largest insect wing ever discovered.
To get an idea of just how big this insect was, this is a reasonably large-sized modern dragonfly. For comparison, it's about 1/5 the size at most of this Meganeuropsis.
Looking at this single wing, it's clear just how big the griffin fly could get. It had 4 wings, the biggest pair spanning 2.5 feet across. That makes it 6 times larger than many modern dragonflies. If it was around today, it would be a match for a hawk and span the outstretched arm of a 6-foot man. From smaller but more complete fossils, experts have discovered that griffin flies didn't merely look like today's dragonflies. Their anatomy was incredibly similar. So it's likely that they behaved the same way too, as deadly hunters. Anthony Leonardo is a world expert in dragonfly flight. He's unlocking the secrets of what makes these flying aces such expert killer beasts. They have 4 wings that can beat independently.
If you look at the wings closely, you can see that they're quite amazing. The dragonfly can fly forwards, backwards, upside down. It can also pull these incredibly sharp 6G turns.
They also have eyes with virtually 360-degree vision, powerful legs for grabbing insect prey, and killer jaws.
They have these massive mandibles and these kind of pinching crunchers, and they very quickly cut and slice all this prey up into little bits that the animal then swallows.
But how did the griffin fly get so big? And why are modern dragonflies so much smaller? The answer lies in the way all other insects breathe.
Insects don't have lungs. On the outside of the dragonfly's body are little openings called spiracles. And these are little holes that open and close, and they basically are little pumps letting air into the dragonfly's body and then pushing it back out.
Once through the spiracles, the air moves through a network of tubes called trachea. This way, oxygen is fed directly to every single cell of the body. The problem is, there are so many tubes, there's little room left for muscle. And that's what stops today's dragonflies getting any larger. So how did they ever reach the monstrous size of the griffinfly? How did they pack enough muscle into their bodies to power giant wings? One paleobiologist at Midwestern University, John Vandenbrooks, believes he has the answer. He's doing experiments to uncover the secrets to what makes a bigger bug. John thinks that growing bigger was all down to the amount of oxygen in the air they breathed.
Oxygen was much higher in the past. Today, oxygen's about 21% of the atmosphere around you. In the past, it was as high as 31%.
An extra 10% might not sound like much, but that's 50% more oxygen than we breathe today.
So perhaps that increase in oxygen in the atmosphere is what led to the possibility that those insects get as large as they did.
To investigate, John decided to do something radical. Change the oxygen the bugs could breathe. First, he takes cockroaches and breeds them at far lower levels of oxygen than today.
In this top chamber, we have cockroaches reared under lower oxygen levels, about 12%. And you can see how large this individual is.
It may look large, but it's actually small for the species. John then rears other roaches at the oxygen levels of the past.
Comparatively, the cockroaches reared down here are being reared in a high oxygen level of about 31%. And you can see now how large this individual is. Much, much larger than those reared at the lower oxygen levels. And it's even more pronounced if we're able to compare the two animals.
The results are clear and astonishing. More oxygen means bugs can have a smaller internal breathing system.
We can now definitively say, as oxygen goes up, it actually allows for the animal to put more things inside its body. So it can have more muscle, and it can become one of these really large, vicious predators that we see 300 million years ago.
Had we been around to witness it, the griffinfly would have been a truly terrifying sight. This was the biggest insect ever to fly Earth's skies. But our next beast is far, far bigger. Fast forward from griffinfly to 27 million years ago. Then the skies were ruled by a feathered giant. With wings as wide as a 2-lane highway and a cruise speed faster than Usain Bolt, it could travel to every corner of the planet. The evidence of this giant first came to light in South Carolina in the USA. In 2010, paleontologist Dan Sepka discovered a collection of bones in a storeroom of the Charleston Museum.
When we pulled open the drawer and I saw this for the first time, it was just absolutely spectacular.
Laying the bones out, Dan could see this was no ordinary find.
It has this skull with these bony, toothed jaws that almost looks like a crocodile.
But it wasn't any kind of reptile. What Dan had discovered was the largest flying bird of all time. A new species they called Pelagornis sandersi.
This massive element here is the humerus. This is the first bone of the wing skeleton, so it's equivalent to the upper arm bone in a human skeleton. This bone in particular is longer than my entire arm, and so we have a remarkably long wing.
The giant bird's body was 6 feet long. With a 24 feet wingspan, the largest bird alive today, the wandering albatross, could fit easily under one of its wings. Pelagornis' wingspan rivaled that of a Harrier jump jet. Everything about the skeleton tells us this bird must have flown. But how could something this big possibly have stayed airborne? A closer look at the bones provides Dan with a vital clue. Like flying birds today, its bones are hollow and super thin.
The bone wall is about 1 millimeter thick, and so this animal would have been very lightweight for its size. There's less weight to support in flight.
It rivaled the wingspan of a fighter jet, but this giant bird weighed only 48 pounds. Less than a third of the weight of an adult human. Light as it was, one bone still cast doubt on its ability to fly.
This bone, the scapula, is the equivalent to our own shoulder blade. And you can see it's just so small. It's actually almost comically small, and this certainly reveals that this bird was not a high-powered flapper.
If it wasn't flapping its wings, how did Pelagornis fly? Flight biomechanics expert Mike Habib believes the answer lies with this.
I'm out here to try hang gliding for the first time. I'm really excited. I'm hoping this will give me some idea of what being a Pelagornis will be like.
A hang glider has a similar wingspan to Pelagornis. It's also lightweight, has a hollow tubular skeleton, and a large rigid wing.
The physics don't change, so an airplane wing or a hang glider wing looks fundamentally very similar to an animal wing, even though they're made of different stuff.
The only way Mike or Pelagornis could get airborne would be to run into the wind.
Hoping that I run properly and we launch and I don't have to be like one of these people that gets dragged along on their face. Okay, you ready to take off? Ready to take off. Okay. This is awesome. Oh man. This is giving me a little bit of a glimpse of what it would be like to be a giant flying animal in the past. This is an amazing feat of engineering, and it's a great way of soaring. But Pelagornis did a lot better.
27 million years ago, nature produced a glider that was about 4 times more efficient than this hang glider. In fact, Pelagornis was a better glider than anything that has ever lived, or that technology has ever produced.
So we were in the air for a good 10 minutes, nice long flight, but Pelagornis would have been one of the champions of long distance flight. Probably could stay in the air for weeks at a time, maybe even months at a time.
Staying aloft for long periods was essential for Pelagornis. Its bony teeth, ideal for catching fish, reveal it was a seabird.
27 million years ago, Pelagornis was living in this open sea environment. Pelagornis could probably travel across thousands of miles of ocean without much thought.
So how did Pelagornis manage such an extraordinary feat? Dan thinks the clue may lie with the modern master of ocean flight, the wandering albatross. Albatrosses make use of the way air flowing over the oceans can change speed. They perform a daredevil maneuver called dynamic soaring. Dan believes if Pelagornis was to survive out at sea, it must have done the same thing.
So if we look at the waves, the wind above the waves is going more slowly than the wind higher up at a higher altitude above the waves, especially out on the open seas. And dynamic soaring birds can use this to their advantage.
They swoop down to the ocean surface, then pull up at the last second. Pulling up gives a bird enough momentum to rise up and catch faster moving air currents. Flying in loops like this, Pelagornis would have been able to cover vast distances and grab fish from the surface whilst burning very little energy. This was the biggest and most efficient flying bird in the history of the planet. It ruled the ocean skies. Pelagornis was at the limit of how big birds could grow and still get into the air. But if you think that's big, coming up at number 8 is an absolute whopper. Imagine walking into a modern zoo where they'd somehow managed to resurrect the largest mammal to walk the earth. What you'd see is this. 20 tons of hide-bound flesh, standing more than 2 stories tall. Evidence of this ancient mega-mammal emerged in the 20th century in what is now Pakistan. But today, this evidence is far from Asia. Paleontologist Mikhail Fortelius is investigating an extraordinary collection of the beast's bones in London's Natural History Museum.
Easy.
This colossal skull is testimony to its sheer size.
The head sits on a very long neck. There's never been anything similar to this.
Put all the bones together, and you get something that looks like a cross between a giraffe and an elephant. It's called Paraceratherium. It was so big, a 6-foot man could easily fit between its legs. It stood 25 feet high. It was nearly twice as tall and 3 times as heavy as the biggest land mammal today, the African elephant. And at 26 feet from nose to tail, it was as long as an Abrams battle tank. Now the obvious question has to be, why did it get so big? But there's an added complication. While some scientists believe that Paraceratherium lived in thick forests, Mikhail Fortelius thinks this creature's habitat was harsh. Afflicted by dry seasons when water was scarce and vegetation sparse. How does an animal become a giant when food is in short supply? Mikhail Fortelius believes the answer lies in the teeth.
Looking at the teeth will allow us to understand why this animal got so very large. The teeth are worn in a way that only happens when you're eating leaves.
And for eating leaves, sheer height would give this animal a massive advantage. Like a giraffe, it could get to food that's beyond the reach of most animals. So that explains Paraceratherium's height, but not its massive bulk. Fortelius believes that the explanation for that can be found in the harsh environment itself, that the animal grew big because of, not in spite of, its tough surroundings.
If you're small, just one day without water is a terrible thing and may kill you. But the larger you are, the more buffered you are, and the more you can deal with harshness in this sense. You can go without food, without water. I think that's what was driving the size increase.
Not everyone agrees with Fortelius's theory, but there's no doubt that somehow Paraceratherium thrived. And it must have consumed vast quantities of vegetation every day. To find enough food, it needed to range over hundreds of square miles. And that may be the reason for what is perhaps the most remarkable thing about this amazing animal: its feet. Biomechanics expert John Hutchinson has analyzed Paraceratherium's foot bones and produced a 3D model. He's struck by just how much it resembles that of one of today's giants, the rhinoceros. In fact, weighing in at only 1/6 of its size, the rhino is Paraceratherium's closest living relative. And Hutchinson's research shows that in terms of size to weight, its feet must bear the heaviest loads.
Rhinoceros, the pressures of its feet are way higher than in a horse, a human, even an elephant. Rhinos already today are living at an extreme in terms of foot pressure, and Paraceratherium seems to have pushed that extreme further.
On the feet of both the rhino and its ancient cousin, there are 3 gigantic, hoof-like nails. There's also a fatty pad designed to act as a shock absorber. The Paraceratherium's foot is proportionally more slender than a rhino's, meaning it has to bear even more stress.
My calculations suggest that Paraceratherium might have borne as much as 50% more pressure on its feet than a rhinoceros does.
In fact, this was the heaviest mammal ever to walk the earth. And John's calculations suggest one extraordinary fact.
Paraceratherium would have put more pressure on its feet than an average tank's treads would put on the ground. That's pretty staggering.
This was the biggest land mammal ever. And with footsteps this heavy, you'd have been well advised to stay out of its path. So far on Top 10 Biggest Beasts Ever, we've met a deadly dragonfly the size of a hawk, a giant bird the size of a plane, and a mega mammal twice the size of an African elephant. But next up is an even bigger beast that could launch into the skies. This is the closest Earth has ever got to a real-life winged dragon. 70 million years ago, while the dinosaurs ruled the Earth, the skies were ruled by pterosaurs. Their name means winged lizards. And paleontologist Gareth Dyke has spent more than 10 years of his life hunting them.
Pterosaurs are interesting because they're the first group of vertebrates to evolve powered flight, long before birds and long before bats.
The hunt has brought him to Romania, to the region of Transylvania, better known as the home of that legendary monster, Dracula.
"70 million years ago, the climate in this area was much different. Big islands in a tropical sea with lush vegetation, lots of animal and plant life, and quite high temperatures. Couldn't be more different to the weather today."
These red sandstone cliffs hold a huge number of fossils. As the rock erodes, more and more are revealed.
So what we have here are some of the bones of pterosaurs that we've collected from this area in the last few years. This one, for example, it's about 6 centimeters in length. So it would have come from an animal that would have had a wingspan of 1 or 2 meters, 6 feet. average size for pterosaurs.
But then, in 2008, Gareth's colleagues climbed down the cliffs and discovered something extraordinary.
This neck vertebrate from the same part of the neck in a giant pterosaur. It's quite short, quite robust, but gigantic compared to a normal-sized pterosaur vertebra that you can see here. And you can see immediately that we're looking at animals of gigantic proportions.
When the neck bone was mapped onto a model of the pterosaur skeleton, it became clear that this was one of the largest members of the pterosaur family ever discovered, comparable to giant specimens found in the USA. At up to 16 feet tall, these massive pterosaurs could stand nearly 3 times taller than a human, tall enough to look a giraffe in the eye. Their front limbs were also vast wings that, when unfurled, could stretch up to 36 feet across, the same as a modern Learjet. It had a beak more than 5 feet long, perfectly suited to preying off other animals. And no living creature has ever had a larger wingspan. While it seems obvious that giant pterosaurs flew, they're so large, experts have puzzled over how they ever got off the ground. We already know that Pelagornis, with its 24 feet wingspan, was as big as a bird could get and still fly. The difficulty of just getting off the ground at this size stopped flying birds getting any bigger. So how did a 550-pound pterosaur with a 36 feet wingspan get into the air? Flight biomechanics expert Mike Habib has made it his mission to find out. He has been studying the bones of one particular giant pterosaur, Quetzalcoatlus. Discovered in Texas, this species is of similar giant size to the one found in Transylvania. Mike focused his attention on the pterosaur's wing.
This is the skeleton of Quetzalcoatlus. You can see the massive bones of the wing. This is called the humerus, it's the bone of the upper arm.
Mike conducted a forensic analysis of the bones.
I used CT scans to look inside of the bones, and I found that most of the bones in the wing were very hollow. The bone wall of it is only 3 millimeters thick. It's mostly air by volume.
This makes the skeleton very light, but inside the upper arm bone, a dense internal scaffold reinforces the bone, especially near the shoulder. And that's not something you see in a bird wing. This bone is far stronger than needed for flight, stronger even than needed for walking. So why would the pterosaur possibly need such powerful forelimbs? Then Mike noticed another clue. A giant groove in the bone. This could mean only one thing: a huge tendon.
A giant tendon would run in along the groove here and then wrap around the wing pivot joint and end up at the tip of the wing. The tendon would have been about as big around as my wrist.
The super size of this tendon led Mike to form a unique theory. The pterosaurs were using the tendon's elastic power to catapult themselves into the air.
Tendons and the muscles attached to them have a certain amount of springiness. You can stretch them and then they snap back. Basically, a giant crossbow.
Mike used the skeleton to model how this might work.
A giant pterosaur like this one, to take off, would start by crouching on its back legs, and then it would unload the legs first, vaulting over the giant wing, and then it would push against the ground, using up all that stored energy and pushing itself as fast as possible into the air.
There is still one living creature that uses this kind of vaulting launch. It's plain to see when you watch a vampire bat take off. But vampire bats only weigh 2 ounces. So could the same principle work on the scale of a giant pterosaur? Mike has come to a local firing range to find out.
So what we have here is a modern crossbow, and it's a very effective way of talking about pterosaurs. Giant pterosaurs would be stretching its tendons by crouching, and the crouch phase would be much slower than the launch phase. So it puts the energy in slowly and then lets it out quick. So I'm going to put in the energy here nice and slow. You'll notice that the limbs on the crossbow are bending. That's the energy being stored in the flexing of the limbs. There's a lot of energy in here. Now when I let it out to fire the bolt, it's going to go really, really fast.
This catapult crossbow stores so much energy, it can fire a bolt at up to 218 miles per hour.
Wow, it's a lot of energy in this bow. It doesn't have much kick because it's really well engineered, but you can tell that bolt's coming out of there real fast.
The crossbow can fire this lightweight bolt hundreds of feet through the air.
Not a bad shot.
But how do these mechanics scale up to a 550-pound pterosaur?
By storing all this energy in this giant tendon, big pterosaurs would have been able to take off like a rocket, launching a mass about the same as a grizzly bear into the air in under half a second.
Mike calculated that pterosaurs only needed to get 6 feet off the ground. That would give them just enough room to unfurl their vast wings and beat for the first time. Then when they're airborne, just like giant birds, they glide. These giants were the largest flying creatures ever, but they would have been no match for the next beast on our list. A snake of astonishing size. This is the story of a creature that looks like it belongs in a Hollywood B-movie. It begins in 2004 in the Colombian region of Cerrejón. A vast mining operation had exposed a fossilized forest dating to just after the extinction of the dinosaurs. Paleontologist Jonathan Block led an expedition to the site. He returned with something extraordinary.
This is what we found. This is a recognizable vertebra. When we originally discovered this, we thought maybe it was the vertebra of a crocodile.
But this was no crocodile. John had identified the vertebra of the largest snake ever to roam the earth, Titanoboa.
This is the largest vertebra from the backbone of a 17-foot-long anaconda, which is the most massive snake alive today.
When you compare the anaconda vertebra to the 60-million-year-old fossil, Titanoboa's true size becomes clear.
That comparison is really incredibly dramatic. It even still takes my breath away.
Using the anatomy of today's giant snakes as a guide, Block's team set about reconstructing Titanoboa's skeleton, piecing together the fragments. They called in fossil snake expert Jason Head to verify their findings.
The numbers that we kept getting were so incredible in terms of its weight, its length, and its girth. At first, I was suspicious we were doing the math right.
At 2.5 feet across, Titanoboa would struggle to fit through your front door. Weighing in at over a ton, it would be 4 times heavier than the largest snakes alive today. And at 45 feet, it would be as long as an American school bus.
So we're looking at a lower jaw that would have been, this long, about 4 times the size of a large giant python today. Titanoboa theoretically could have probably opened its mouth wide enough for you or I to actually stand in it.
Right.
What's clear is that this snake was simply too large to live on land.
Because it was such a massive snake, it would have had trouble supporting its own weight. This animal probably would have had to spend most, if not all of its time in the water.
And it would have found plenty to prey on.
In its ecosystem, Titanoboa lived with giant crocodilians, it lived with giant turtles and these giant fishes, and it probably could have eaten all of them.
It's some 60 million years since Titanoboa became extinct, so it's a little difficult to meet one now. But again, experts can use today's snakes to get close. This is a reticulated python, the longest species alive today.
These are the closest living relatives to Titanoboa, and a lot of their anatomy is similar to Titanoboa, and from that we infer very similar behaviors. Constriction, ambush predation. In the case of anacondas, living in aquatic environments.
At this moment in our interview, Goldie the python chooses to flex her muscles.
That's better.
This isn't an attempt to treat Jason as prey. It's simply her normal movement.
She in a good mood still?
But when actually on the hunt, she's deadly.
When boas and pythons constrict their prey, they're putting so much pressure on the circulatory system of the prey animal that they actually induce a heart attack. They can stop the heart by squeezing so hard.
Snakes have been recorded constricting at 25 pounds per square inch. Delivered by a snake Titanoboa's size, that would easily be enough to crush prey as big as a rhino. To find out what this kind of force looks like, snake expert Rhys Jones is overseeing a little test, using a collection of heavy machinery.
We've got an experiment set up which will help us to try and visualize exactly the type of forces needed to overcome these huge prey items. So what we've got here, we've got a truck. This is fixed in place. This big yellow rope here is representative of our snake, and it's got, as you can see, 2 coils here around this oil drum. The oil drum is representing our prey item. It's full of water, it's sealed. That's gonna take some pressure to be able to crush that. So we're gonna need muscle.
Cue a 7-ton tractor with a 190 horsepower engine. This versus a sealed barrel ought to be a tough test. As the tractor pulls on, the pressure passes 25 psi. That's the pressure of today's largest snakes. But Titanoboa had 4 times the muscle mass, and estimates say it could pull off crushing forces of up to 110 pounds per square inch. The same pressure as having an 8-ton truck parked on your chest.
It's just squeezed it like a toy, hasn't it? That is just incredible. I think our snake pretty much nailed it, don't you?
It only took 55 psi to burst the barrel, half what Titanoboa might have done. More than enough to crush the life out of any living thing.
I mean, look at the damage to this oil drum. Could you imagine if that type of pressure was applied to you? You wouldn't last 2 seconds.
Titanoboa's phenomenal crushing force made it the apex predator on Earth for 10 million years. Titanoboa was the largest snake in Earth's history. nearly twice the wingspan of the biggest flying bird, and 9 feet longer than the wingspan of the largest flying creature. But as massive as this predator was, next up is a beast even bigger and more terrifying. At first glance, this beast looks like a cross between a giant turtle and a mega crocodile. But what this submarine-sized sea monster really was, and how it became apex predator, has become a 100-million-year-old mystery. In 2003, new evidence came to light on the south coast of the UK. If you're looking for fossils, the Jurassic coast of Dorset is one of the most fertile hunting grounds on Earth. Kevin Sheehan has been coming here for more than 40 years.
I saw 3 pieces of what I thought was fossilized wood. I got really excited because I thought, wow, there's got to be more of this. And then, joy of joys, there's this huge piece of bone stuck. It's almost like a meteorite that's gone bang into the cliff.
Embedded in the cliff were dozens of pieces of fossil. Reassembled, they made something incredible. The most complete skull ever discovered of a Pliosaurus. Paleontologist Richard Forrest is an expert on these ancient monsters.
This is a giant killing machine. This pliosaur was the top predator. It was the peak of the pyramid. They were basically just big, powerful brutes that devastated anything in their way. It's an awesome animal.
The biggest known Pliosaurus had flippers 9 feet long. That's like a basketball player at full stretch. If it swam in today's waters, it would have been bigger than a Navy patrol boat. That's 45 feet. In terms of weight, it would have taken about 44 compact cars to balance out one Pliosaurus. The strongest biter alive today is the saltwater crocodile, with a bite force of 1.8 tons. Pliosaurus had a bite nearly 10 times stronger. It was the T-Rex of the ocean.
We have these great teeth at the front, which is where it grabs the prey. That's what catches it. Then it moves a bit further back. Then another set of teeth. And these are the ones that cut the prey up into pieces. Then you have these teeth, which are hooked backwards. So once the prey gets to there, there's no way out.
But that throws up questions. If you're going to bite something, you've got to be able to catch it first. So how does a 45 feet predator the size of a large shipping container keep up with its prey? The secret must lie in their 4 boat-sized flippers. The closest match to a Pliosaurus flipper today belongs to a creature altogether less frightening. Penguins may look funny when they waddle on land, but underwater, they're like rockets, whizzing around at speeds of up to 20 miles per hour. Biomechanics expert Flavio Nocca is trying to understand how they reach these extraordinary speeds. Using a high-speed camera, he films penguins moving around underwater.
This camera is actually able to go up to 12,000 images per second.
That means that every minute detail of flipper action is captured. Flavio's footage reveals that penguins aren't swimming with their flippers. They are flapping them like a bird. They're flying underwater. And by twisting their wings as they flap, penguins can propel themselves forward on the upstroke as well as on the downstroke, which is something most airborne birds can't do. The Pliosaurus had not 2, but 4 flippers, and they were gigantic. All signs point to this mega monster being not only one of the biggest, but also one of the fastest predators in the ocean. Aerospace engineer Luke Muscat is investigating how they moved. Using X-rays of fossils, Luke has recreated a pair of pliosaur flippers he calls wings.
Pliosaurs were really good swimmers, and the aim of the game is to chase down the prey. And obviously, to do that, you need to be very fast. You need to have a high thrust and a high acceleration.
By suspending the wings in a tank, he's trying to determine how the front and back wings work together to propel the Pliosaurus. Blue and red dyes reveal how each wing moves the water. Luke moves the wings together in different ways and records the amount of propulsion generated. He notices certain movements have a remarkable effect on the back wing.
So initial results suggest that the hind wing can produce a thrust which is about 50% higher than a wing operating on its own.
By harnessing the wake of the front wing, the Pliosaurus could generate 2.5 times as much thrust as it would with just one set of wings. And that is how this mega beast gained sudden and tremendous acceleration. Its prey wouldn't have stood a chance. Pliosaurus is just the latest on our lineup of the top 10 biggest beasts ever. So far, we've revealed Griffinfly, the biggest insect in Earth's history. Pelagornis, the largest flying bird. Paraceratherium, the greatest mammal to walk the Earth. Giant pterosaurs, the largest flying creatures ever. Titanoboa, the largest known snake of all time. And Pliosaurus, the largest predatory marine reptile. But coming up is a bizarre dinosaur that beats them all. New discoveries of one of the strangest dinosaurs ever are rewriting the textbooks. A monster dinosaur with vicious teeth. Claws almost as big as a human arm.
We're talking something of enormous length that could slice you with one motion.
And a massive spiny sail.
The spines are taller than a person. Every now and then, we come across really bizarre dinosaurs. In my book, it's the most bizarre dinosaur out there.
Paleontologist Nizar Ibrahim was on expedition to the Sahara Desert in Morocco in 2013. When he saw the beast's bones, he knew he had something special. This was a Spinosaurus, or spine lizard. It lived 100 million years ago. Everything about Spinosaurus is vast.
Seeing it in front of you, you realize, wow, this is one big predator.
That 7 feet spiny sail means Spinosaurus stands twice as tall as a human. At 50 feet long from snout to tail, it is 10 feet longer than T-Rex. It's so big, it's the size of a fire truck. Weighing in at 22 tons, this is the biggest predator to ever walk the Earth. But Spinosaurus wasn't the only dangerous dino on the block. 100 million years ago, this desert was a vast river system bursting with other giant predators.
I call it the River of Giants because it was home to giant fish, giant flying reptiles, several T-Rex-sized predatory dinosaurs. It was probably the most dangerous place in the history of our planet.
It's jam-packed with all these predators to the point where you say, what were they living on? Where were the herbivores to support this many predators?
It was a mystery. With so few plant-eating dinosaurs to feed on, what enabled Spinosaurus to survive here and become the biggest predator of all? As Nizar and his team looked closer at the bones, they began to find clues. Strange features that marked this predator out from other dinosaurs, like T-Rex.
This animal didn't look anything like T-Rex or other predatory dinosaurs. It was like working on an alien from outer space.
For starters, the teeth were an unusual shape.
Spinosaurus, it's really all about grabbing prey and holding it in these massive jaws with long conical teeth. So these teeth are great to grab slippery prey.
At over 5 feet long, these jaws were capable of swallowing prey the size of a person whole. Next, Nizar noticed that for a predatory dinosaur, the front limbs were unusually long. Though not all experts agree, Nizar believes Spinosaurus may have even walked on them. And the back feet were just as strange.
Now, the feet of Spinosaurus are really bizarre. Typically in predatory dinosaurs, the claws will be recurved to grab prey and pin it to the ground. In Spinosaurus, the claws are almost flat and they're quite wide. Almost looks like a paddle. And I think it's quite likely that the feet of Spinosaurus were webbed, just like in many birds or crocodiles.
This has more to do with paddling and swimming than running on land.
Everything was pointing in one direction. This looked like a beast that swam and hunted in water.
This was a dinosaur that was doing something no other predatory dinosaur was adapted to do.
This is a river monster.
This was an extraordinary discovery. It suggested Spinosaurus hunted fish, giving it a major advantage over the other dinosaur predators. But if Spinosaurus was swimming, how did it hunt? How could something this bulky chase down enough fast-moving fish to grow to monster size? To find out, the team scanned the bones. A CT scanner allowed scientists to record the fossils in 3D and see inside them. Suddenly, the skull from another Spinosaurus started to reveal new secrets.
This is the tip of the snout of Spinosaurus. So when you look at the outside of the snout, you have all these openings, and it's really unusual.
The CT scan revealed that inside the skull, a complex network of tubes runs from the holes to the brain.
It's really a network of openings. And so clearly there's something happening there. There's probably some kind of sensory function.
It reminded Nizar of some of today's deadliest predators. Crocodilians. Crocs and alligators have similar holes on their snouts. They're called foramina. And for many years, they too mystified experts. Neurobiologist Daphne Suarez made it her mission to find out what they were for.
Wow, as you can see, these animals are really well adapted to living in the water.
Daphne devised an unusual experiment. She put young alligators into a tank, blocked up the foramina on their snouts, and then turned out the lights.
I have the animals in complete darkness so they can't see, their ears are covered so they can't hear.
Then, to mimic the movement of small prey falling in the water, Daphne hit upon using water droplets.
And I'm using water droplets because they don't smell like anything.
With all their senses neutralized, the alligators didn't react at all. Then Daphne unblocked just the snout holes and repeated the drip test. Daphne's experiment revealed that the openings in the gator's snout hid pressure sensors that can pick up the tiniest motions in water. This super sense gives crocs an astonishing reaction speed of 0.05 of a second, as fast as a Lamborghini gear shift. The holes in Spinosaurus's skull likely hid similar pressure sensors.
This is the super sense that allowed Spinosaurus to become the ultimate predator.
You can just imagine Spinosaurus plunging its huge jaws in the water and detecting movement and then catching prey.
This super sense and the ability to hunt in water as well as on land made Spinosaurus the biggest predator to ever walk the earth. But coming up, the next giant beast is the biggest apex predator of all time. Stalking the oceans from 16 million to 3 million years ago, the biggest apex predator ever, Megalodon. The name simply means big tooth, and it seems to have been the most voracious shark ever.
There was nothing that was safe from Megalodon. If it could catch it, it could kill it.
Much about this giant remains mysterious. But new clues are coming to light in Panama, Central America. In, of all places, a cement quarry. Here, giant excavators are digging through the bed of an ancient coastline.
10 million years ago, this area was covered by water. We know that because of the kinds of fossils we find here. For example, we find plenty of these shells that are typical from shallow water areas.
But as well as shells, paleobiologist Catalina Pimiento is also finding megalodon teeth. And there's something strange about them.
The teeth that we find here from megalodon are very small, relative to the typical megalodon teeth that we find in other places. I know these are megalodon teeth because of particular shape. They are triangular and quite symmetrical, but most importantly because of the serrations they have on their edges.
There's only one logical conclusion.
The reason is that most of them were babies or juveniles.
Catalina has made an astonishing discovery. The first ever evidence for a megalodon breeding ground.
This area right here is the first nursery area for megalodon.
But even amongst these infant specimens, megalodon's extraordinary size was striking. That baby's teeth were as big as those of today's deadly giants, the adult great white.
This is a megalodon baby tooth, and this is an adult great white shark. You can see here that the baby megalodon was as big as an adult great white. So imagine when they were born, megalodon babies were huge.
The fact that Catalina had to make her deductions using teeth alone isn't unusual. In fact, almost everything that experts know about Megalodon comes from looking at its teeth.
We don't find the skeletons of Megalodon because, just like living sharks, they're made of cartilage, and after the shark dies, the cartilage disintegrates. But we do find their teeth, and we can use these teeth to recreate what the jaws would have looked like when Megalodon was alive.
What they tell us is that the adult Megalodon was a Goliath. Its jaws alone were up to 7 feet high, easily tall enough to swallow a person. Weighing in at a whopping 100 tons, it was 100 times heavier than an average great white. And at 60 feet long, it was the length of an articulated truck. And that jaw. Up to 250 teeth line the mouth in several rows, with edges serrated like a steak knife.
I mean, these teeth are just so powerful. The massive jaw muscles that this animal had to close these jaws, it would just dismember any animal that was alive on Earth at that time.
And Stephen has evidence of just what these jaws could do to prey.
We know from the size and shape of this bone that it is a dolphin tail vertebra. It's right down near the fluke. There are these deep gouges on either side. The only way that this fossil could have these deep gouges was that it was bitten forcefully by a megalodon. Okay, so if we look at a megalodon tooth, so the upper jaw slams shut, forcing the vertebra down into the wedge between two adjacent teeth, deeply gouging the bone with such force that it probably severed the tail off.
Everything points to an astonishingly powerful bite. And one man who has set out to calculate exactly how strong that bite is shark biomechanics expert Dan Huber. Dan starts with a CT scan of the skull of a modern great white.
After the white shark's head is CT scanned, we can create a computer model of it. We can see the lower and the upper jaws here, and then we can apply virtual muscles to those virtual jaws and run simulations to figure out how hard it can bite.
Next, Dan scales up to megalodon size.
And if we apply these numbers to what we think is the biggest megalodon that's ever existed, its posterior bite force was about 41,000 pounds, or about 18,500 kilograms.
That's like the weight of a garbage truck pressing down on the back teeth. So what does a bite force of this size look like in action? To find out, Dan is going on a mission. He's joining up with the Tampa Fire Brigade. And a piece of kit they use for cutting victims out of crashed cars. The jaws of life.
It's lightweight, it's really easily deployable.
So is this thing going to be able to generate 41,000 pounds of bite force? The corner of it?
Absolutely, that's exactly where it's going to cut. So this shouldn't have any trouble at all when we need to cut open cars.
So that's actually pretty similar to what we're looking at with this ancient shark megalodon. All right, let's see what this thing can do.
All right, let's do it.
First, Dan tries out the jaws on a cow bone. Something similar to what Megalodon got to chew on.
Let's go ahead. See, it split the thing in half, no problem at all.
Next up is the car. The jaws of life can deliver the same kind of bite force as Megalodon, only far more slowly. Megalodon was capable of biting through the car in a split second.
From this, we know that Megalodon could tear through ancient whales, we know that it could tear through ancient sea turtles, and apparently it could even tear through this car. Megalodon was the biggest predator that's ever existed, and its bite force was the highest bite force that's ever happened in any animal in the history of the planet.
Megalodon tops all other apex predators. It was nearly 1.5 times the length of Titanoboa. It was more than twice the mass of Pliosaurus. And it would have dwarfed Spinosaurus. But though this giant shark was the biggest apex predator ever, it shared the oceans with something much, much bigger. They are the largest living creatures on Earth, and the heaviest in history. Propelled by vast tails, they spend much of their time in the deep oceans. But every year, come summertime, blue whales appear in the waters just off Los Angeles. For ecologist Ari Friedlander, it's an unmissable opportunity to study them.
You get close up to them and you start to see how big they are. You start remembering what it feels like to be this tiny little person in a pretty small boat next to this enormous whale. It's kind of daunting, you know? They're huge.
The numbers are awe-inspiring. The whales are so big compared to a person that 90 of us could fit on its tail alone. Its 200-ton bulk makes it 30 times heavier than an African elephant. And at 100 feet, it's the same length as a Boeing 737. So how does a mammal get so big? It's only when a whale washes up dead on the beach that scientists get a chance to really study their anatomy.
So now we're in the rib cage of the whale, and on either side of the rib cage would be the lungs. You've got the heart, you've got the stomach.
A heart the size of a car connects to 1 million miles of blood vessels, enough to reach to the moon and back twice. But there's one feature that's supersized beyond all others: the mouth. Rather than hunting one big animal, blue whales use their enormous mouths to catch entire shoals in one go. They feed on tiny shrimp-like crustaceans called krill.
Many people think that it's amazing that the largest animal that's ever existed feed on such a tiny animal, but no blue whale's going, oh, there's a krill, I think I'll take that one. What they're doing is they're trying to find huge, dense swarms of krill, and a prey item for a blue whale is not one of these guys, it's thousands and thousands and tens of thousands of these guys.
Though the whale's gullet is so small it would choke on a loaf of bread, its mouth can take in 220 tons of water in one go. For anything roughly comparable, you'd have to look at something like this. The DC-10, a specially modified firefighting airliner. It swapped passenger seats for a massive water tank.
This is the biggest tanker flying in the world. It carries 12,000 gallons or 44,000 liters of liquid, which is roughly 4 to 10 times the size of any other airplane.
Used to fight forest fires, the DC-10 releases enough water to cover the length of 10 football pitches in a single drop. But a blue whale picks up 4 times this much water in a single mouthful.
We're very proud of this machine, but if the whale could fly, we'd hire the whale because it's 4 times bigger.
The whale more than doubles its weight with each mouthful. And what follows is one of the weirdest operations in the natural world. When the whale opens its mouth to feed, the water pushes its elephant-sized tongue all the way back to its belly button. The tongue is super stretchy and expands out, lining the mouth and creating a huge sac full of water and krill. Then, mouth closed, the whale rams the tongue forward like a piston. It forces the water out through sieve-like grills called barlines until only the krill is left inside. The energy required to perform this maneuver is colossal. In fact, in a single day, blue whales burn up to 3 million calories, the equivalent of 10,000 hamburgers. How does a creature burning this much energy find enough food to become a giant? The answer must lie in how they hunt. But as whales hunt krill hundreds of meters underwater, witnessing this behavior has been almost impossible, until now. Ari Friedlander is using a tag that enables him to spy on whales even when they're deep below the surface. It contains a camera and motion detectors like the ones found in a smartphone. All he needs to do now is attach it to a 200-ton whale.
You always are a little nervous approaching them. They're wild animals, so you never know how they're going to react.
Ari gets into position. Tag in place, the whale disappears into the depths, and Ari returns to base to track it on his computer. As he plots the whale's position in 3D, he spots something extraordinary.
Incredibly exciting. Up until now, we basically thought they just went through the water, taking these munches and lunging sort of in a straight line. But we noticed the animals diving down to depth and then doing these 360-degree rolls. This kind of acrobatic maneuvering is something we had no idea an animal this big could do.
Images from the camera reveal the whale rolls just before it opens its mouth to feed.
This is the mechanism that allows whales to get so big. If you're a whale, your eyes are on the side of your head. They don't have this binocular vision like we have where you can see directly forward. So in order for that animal to see its prey in front of it, it kind of needs to roll its body. So you maximize the amount of food you get and you limit the amount of energy it takes to do it.
Far from just hoovering up krill like a 200-ton deep-sea juggernaut, it turns out the blue whale is the ocean's biggest acrobat. So far on Top 10 Biggest Beasts Ever, we've met the hawk-sized griffin fly, a bird the size of a fighter plane, a mammal as big as a tank, a pterosaur the size of a Learjet, a snake the length of a school bus, an ocean killer nearly 50 feet long, a dinosaur that dwarfs T-Rex, a shark 100 times heavier than a great white, and the largest creature ever to swim Earth's oceans. The blue whale is very nearly the largest beast that's ever lived. But there's one beast that's even longer, and it takes the title of Biggest Beast Ever. March 2015. In southern Argentina, in the remote province of Patagonia, a team of paleontologists is on standby. Lucio Ibericu has been waiting for this moment for months.
Ok, finalmente el titanosaurio acá en el museo. Llegó a casa.
Inside this truck are some of the biggest bones on the planet.
It's very good, very happy. Everything here now.
And after 5 years in the United States undergoing scientific analysis, they're coming home. More than 50 crates hold the bones of just one dinosaur. Each bone is enormous. Yet, as big as they are, these bones are just a clue to a creature that was even larger. The biggest beast ever to walk the earth. The journey to this moment began in 2005. Lucio was part of a team of paleontologists prospecting for dinosaur bones. They were in a remote area of Patagonia known as the Badlands.
75 million years ago, this area was completely different. Warmer, more green, humid, a lot of vegetation, and several rivers.
The ancient rocks reveal the area was once a perfect habitat for dinosaurs. But today, the lush forests have given way to harsh desert. As the team surveyed the land, one of them came upon a small piece of exposed bone.
The first thing that we see was the middle part of the femur. So we start to dig and continue digging, and we never finish with that. So we say, okay, this is the femur, but it's huge.
You sit there and you look at this object and you realize that you're the first person to ever see this thing. You're the first person in history to know about this.
They had found a giant thigh bone, over 6 feet long.
So this is the femur. This is a leg bones. It's bigger than me, and it's just one bone. This is amazing.
It's hard to imagine, but bones of a beast bigger than this have occasionally been discovered. But what was remarkable about this find was just how complete the skeleton was. It took several expeditions to uncover it all.
At the end of 3 seasons of excavating there, we had 145 bones.
And the state of them was surprising.
The preservation of the dinosaur was very good. A lot of bones that we found are in the same position as when the dinosaur died.
The team were now in possession of what was effectively a time capsule. One that could revolutionize our understanding of the biggest beasts to ever roam the Earth. Ken took the bones back to his lab in Philadelphia. Here, careful cleaning, 3D scanning, and forensic examination all started to reveal how these extraordinary beasts looked and lived. The beast's sheer size was apparent at every turn.
The scale just staggers the imagination. This animal was 85 feet long from head to tail. It was 2.5 stories tall at the shoulder.
This was a new species of titanosaur, a plant-eating dinosaur of almost unimaginable proportions. Ken named his titanosaur Dreadnoughtus, meaning fears nothing.
Dreadnoughtus isn't going to have anything to worry about in terms of predation. These are big, nasty, capable, vigorous creatures that deserve a lot of respect.
Dreadnoughtus was clearly a mine of information for the scientists. But it held one surprise, which relates directly to the size of the very biggest titanosaurs. Cutting into the bones, Ken started to find evidence of how old this Dreadnoughtus was when it died.
You see here these big oval bone cells here. That's indicative of bone that's not growing anymore. And then as we move towards the outer edge of the bone, you'll notice that that texture changes. And that is indicative of rapidly growing bone.
And that could mean only one thing. Ken's Dreadnoughtus, though vast, was not fully grown.
We know that it was growing rapidly when it died. So 65 tons and not yet done growing. That means there are bigger Dreadnoughtus out there. We don't know how big this dinosaur could have gotten.
But then comes another clue. Titanosaur wasn't like our other giants, Megalodon and blue whale. It didn't start life at monster size. Paleontologist Gerald Grellet-Tinner has uncovered stunning evidence that reveals the last piece of the jigsaw. He's investigating a site in northern Argentina, an area that was once a harsh volcanic landscape.
So here we're sitting on the top of a geothermal formation.
At the time of the dinosaurs, this area was a geothermal hotspot, with steaming vents and hot water pools. Gerald has found evidence that titanosaurs came here to lay their eggs.
What we have here is a clutch of about 24, 25 titanosaur eggs. And this one here, it's probably the biggest one. And I would say maybe more than 8 inches in diameter.
Remarkably, as big as titanosaurs were, their eggs were about the same size as ostrich eggs. But some of them have incredibly thick shells.
As you could see, this one, for instance, it's very, very thick. And it's about 7 millimeter, and this is virtually impossible to break. So a chick will not be able to break that eggshell.
Gerald thinks that the shells began this thick to shield the embryo inside from the geothermal chemicals. But then these chemicals helped make it possible for the baby titanosaur to hatch.
The harsh chemical is eroding the eggshell from the outside to the inside, thinning down the eggshell to probably 1.2, 1.23 millimeter, which is perfectly acceptable for the chick to break.
And for an incubating egg, the choice of this site offered a major plus. It had constant heat. But baby titanosaurs had one big problem. Once hatched, they were no bigger than domestic cats. Not great in a world teeming with hungry predators.
There's a premium on growth when you're on the menu. And so they grow very rapidly to get to the point where they can be impervious to predation.
And going from the size of a cat to having thigh bones over 6 feet long means one serious rate of growth.
Baby titanosaurs have an early burst of growth, and that burst never stops. They just keep growing as fast as they possibly can.
It should now be possible to pull all the clues together and build a picture of what these beasts looked like. Starting with scans of the bones, Ken Lacavara works on a 3D digital model of Dreadnoughtus. The completeness of the skeleton means this model is far more accurate than for any previous titanosaur. And this gives us an amazing opportunity. We can take the model and scale it up to match the bones of Argentinosaurus, the largest titanosaur ever found. Only a handful of Argentinosaurus's bones have ever been discovered. So this may be our best possible chance to fill in the blanks and see what the beast might have looked like. Just how big that is must be seen to be believed.
So, one of the best way to have an idea how big this dinosaur could grow is to measure it. So we are going to start with the tail.
Using Dreadnoughtus's skeleton as a guide, Lucio maps out how Argentinosaurus may have stood on this ground. Its tail alone would be the length of Titanoboa at 45 feet.
So this is the tail.
Adding its body takes Lucio to 70 feet, longer than Megalodon.
So this is the tail and the body, and now the neck.
The neck and head is another 60 feet, giving a total length of 130 feet. That's bigger than blue whale and Paraceratherium put together. All the pieces in place, it's time to reveal the biggest beast ever to walk the earth. Meet Argentinosaurus, the biggest beast ever.
From the tail to the front of the head should be about 130 feet.
towering over 30 feet in the air without even lifting its head, and with a neck like the arm of a crane, the biggest known titanosaurs would have been a fearsome sight. Standing over 3 stories tall, a 6-feet person wouldn't even reach the knee of an Argentinosaurus. At 90 tons, it likely weighed as much as 11 T-Rexes. And 130 feet from tail to mouth, it was the length of the Space Shuttle orbiter. Titanosaurs were mega versions of long-necked, long-tailed sauropods like Diplodocus. Just their stomachs alone were likely the mass of an elephant. And just 1 foot was big enough to crush 20 people. So what was the secret to their mega size? Well, an answer appears to lie with the one thing about Titanosaur that isn't gargantuan. Its head. A titanosaur like Dreadnoughtus only had a head as big as that of a horse. And that's because it didn't chew its food. It just grabbed and swallowed.
The skull is basically a plant vacuum. They don't have the ability to chew.
What that means is that a titanosaur had the capacity to consume over 2 tons of vegetation every day. That's enough salad to feed 40,000 people.
Dreadnoughtus could stand in one place with its massive body and not move that body, and maybe spend an hour taking in tens of thousands of calories. And then at the end of that, take a few steps to the right and spend another hour or so clearing out another giant envelope of vegetation. So by expending very few calories itself, it takes in massive quantities of food.
This basic strategy made titanosaurs some of the most efficient eaters of all time, and it allowed them to reach monster size. And yet, as big as they were, experts are convinced that somewhere out there, hidden in the rocks, are even bigger specimens still to be uncovered. The top 10 biggest beasts ever are giant creatures at the top of their evolutionary trees. Beasts that hunt, kill, walk, swim, and fly at sizes that dwarf all others. Between them, they've mystified scientists, broken the record books, and colonized every continent on the planet.